Okay, we got a package from WyoLum. If you're not familiar with them, they make word clocks, and I actually have quite a few of these that I've built over the years from the kits they've made. And this is a new version that's going to have internet connectivity, so should automatically set the time through NTP. And I believe it's already assembled, so haven't opened it. I exercise extreme patience and not tearing into it. So let's take a look at it. So let's see. All right, let's see. Should be the power supply and the clock itself. Wow, yeah, this is awesome. Oh, I love that font too. Let's see here. A wire tie. Oh, look at the strain relief on the cables. That is, I've never seen that before. It's pretty slick. This looks really good. So this is called the ClockIOT. The previous names were, there was Clock 3 and then Clock 3 Junior. I think there was one in between that too. But I'll post them all down below here. Let's see. So that lovely, how you doing? That lovely shine from the light there, but yeah, that looks really good. And this board is, it's amazing how they've shrunk the process down over the years. See, you can see in there a little bit. But looks pretty good. Looks like some kind of an ESP32. Can you see that? I don't know if you can. This solar module there. Looks like an ESP32. Now, I didn't actually look at any of the specs of this yet. I kind of wanted to be surprised by it. So let's see here. This is what it would look like normally, except for that giant shine off of the light above. Take a look at this power adapter. So it's a worldwide universal adapter. Maybe you should trust me on that. Well, let's see. We've got probably UK and Europe-ish, which those will be fine. All right, let's plug this puppy in. Let's see here. Now, I'm going to treat this like a normal user, and I'm not going to read any instructions. My guess is there's going to be a captive portal that I need to connect to. But we'll see here in a second. Maybe I should actually read some instructions. All right, I'm gonna have to read some instructions. I'll be right back. Okay, so what we've done here is connected to the clock SSID. This is the captive portal. It's KLOK. And we're gonna select my SSID for my network and put in my super secret password. And then after we save this, the clock should reboot, and it should query NTP and come up with the correct time if all goes well. Okay, so we got it up and running, and the initial config was pretty good. We've got the correct time, at least according to my time zone. And Something I noticed too is looking at RGB LEDs versus the previous kit that I had was just single color, just white. So that's kind of nice. So let's take a look at how you configure the rest of the device. So you can obviously customize it and do other things. I'm also kind of a real nerd about this stuff, so I kind of want to know how it all works. Now, it's open source project, all the stuff's here, but part of the fun for me is kind of reverse engineering this. So if you go to the wiki on the page here, they've got just a couple of instructions here because it's pretty simple to set up. But let's take a look at the Quickstart. So I already did this first bit where we connect to the clock captive portal and configure the Wi-Fi, and then it connected to NTP, and also got a time zone. And I was kind of curious how this worked. Well, at WyoLum, they've got a script that will look at the IP of the connecting client and just, basically reverse engineer the location, via, IP address to, it's kind of a guess of the time zone, but it's going to be accurate for most cases. But then what I thought was kind of interesting was, you can actually click on this link here to control the clock. And this is where my mind got blown a little bit. So let me do that real quick. I wasn't sure how they were doing this. I thought maybe they were probing the local network somehow from the browser, but that should be mostly impossible. I won't say it's completely impossible. But most of these browsers are sandboxed, and the APIs to do any kind of local interaction don't quite exist yet without some sort of client-side component. So, that piqued my curiosity. So I figured, well, let's go ahead and, because I'm a big nerd about this stuff, take a look and see probably how they're doing that. And if we reload the page, we'll notice that there's a request out to... Actually, let me just clear this off again and start from scratch. There's a request here, if I can find it, to get local IPs at WyoLum. And if we actually go directly to that URL, we'll see some JSON that shows the IP on my network, which that is the IP of my clock. And I was kind of curious. I mean, I think I know what they're doing here, but I figured I want to just test and trust and verify. So let's go ahead and see what happens if I connect from a different location with my browser. So my clock isn't going through this network, but my laptop is. And if I refresh this page, should be blank, which makes sense. So I think this is kind of an elegant way that they're making it easy to configure the clock. You don't have to find the IP address and know any of that information. And they're working around some of the limitations, and they're good limitations that the browsers impose. So that's cool. So anyway, let me get rid of that, get out of here. And if we refresh again, we'll see, boom, we're back. So the other thing I noticed too is I did a quick scan of this device with an Nmap and noticed port 81 was open. Tried to connect to it and realized that it's just for WebSockets. So my guess was that they were using essentially JavaScript in the browser here to connect to that over WebSockets. So we'll go ahead and we'll filter by WebSocket now. And if we take a look at this dialog and go to our clock, we see something pops up. Now, if we come back over and look at our WebSocket messages, we'll see messages that are being sent back and forth to the clock, which is pretty cool. Now, this is all local. This all stays local. And what's nice about this is they can update the UI and not have to touch the clock and not have to flash the clock. And in theory, the firmware updates to the clock could probably stay more static than they would otherwise. They could add functionality here and use the API they've built with WebSockets to do more. And that's a neat way, I think, to get something quicker to market, get it through manufacturing, and have the ability to build the things that are probably that take a little bit longer, like the UI and that sort of thing. So I thought that was pretty neat. But let's go ahead and see what we can do here. Okay, let's look at the new web interface for the ClockIOT. What we saw before, I think I would probably classify as a beta interface. It worked mostly. Obviously, the color picker did not. So this interface was created as a collaboration with Evil Genius Labs, and we'll talk a little bit more about them in a moment. But so now if we take a look at the interface, it doesn't look a lot different, but you might notice there's some slight changes here. First off, it's using more of a responsive design, so depending on the browser you're using, like if it's a mobile browser or something like that, the page will actually render properly, so it should be helpful in those situations. Also, the color picker now actually does something. So before, we just got a representation of what it was going to look like, and now it brings up the operating system's color picking UI. So switching here, we'll actually see that we'll go and have different colors pop up down below, which is pretty cool. And as before, we have the ability to change the brightness. We'll crank it down a little bit so it doesn't wash out the image. Of course, we can select a time zone. So if time zone's not automatically detected for whatever reason, it could be in a fringe area between some time zones, and depending on your ISP, your egress point might show up differently, or your IP address that you get might not be reflected accurately. So there's a way to change that there. So that's nice. And then of course we've got the different patterns. So if we walk through these kind of briefly, we see plain here, which is actually rainbow. Not sure quite why it's called plain, but hey, it's plain as far as we're concerned here. A couple of my favorites are this cloud one. I really like this one. It's pretty soothing. It kind of emulates clouds moving through a blue sky. I really do like that. And then the fire one is also pretty slick. Looks like a fire. And I like that. I think it's pretty cool. There's also this glitch one, and this one is basically the plane with little glitched pixels, intermixed randomly. So you'll see the pixel kind of like flash white, to kind of look like a broken display or something like that. So I don't know if you do that just to drive people crazy or or what. But one of the other ones I really like is the matrix. So there's a couple of these patterns that they don't do anything until a certain time. So the matrix is one of those. So each time the clock will change, the display will change. So every 5 minutes, roughly, not roughly, exactly, it'll redraw the display in a matrix style. So we'll wait here just for, it should be less than a minute before this comes up. There you go. So that's pretty cool animation. And then the other one that does that is word drop. So again, it'll take about 5 minutes for that to kick off, but the default display is going to be the plain display, which again is that rainbow. But while we're waiting for that to click off, I wanted to talk a little bit about Evil Genius Labs, because I thought that you may not know about them. I've seen some of their stuff they've done before, and I thought it was pretty cool that they were working with them. But apart from the art installations they've done, which have got a pretty cool bunch of different things they've done, they also have some products. So if you look at their the portfolio here, you'll see some of the stuff they're doing. But the products page actually has quite a bit of LED related options. So one of them that I was pretty interested in was this Wemos D1 Mini controller. So I use a lot of these string lights, these pixel string lights, and these are individually addressable. So each one of these pixels here, can be controlled, separate from the rest. So there's a lot of cool things you can do. I'm using them for Christmas lights. And this year I had just a very bland display, but my plan is to kind of crank it up next year. And one of my challenges is that
while we're using something like a Wemos D1 Mini, which is pretty popular for this, so it's an ESP8266 Wi-Fi controller, very cheap. I mean, you can get 5 of them for like $15 ish. And then, you have to do the soldering and everything like that. One of the things you have to do is, well, you don't have to, but you should, is level shift the signal lines coming out to those pixels LEDs. So what happens is you've got a positive, negative, and then a data line that comes in, and that data line talks to the protocol that will switch on and off those individual pixels and control the colors for them. That's a 3.3 volt logic level coming out, and what it's really expecting is 5 volt. Now, for the most part, it works. You can just connect it directly into the GPIO pin of one of these Wemos, and it'll usually work as long as the controller was within about a foot of the start of the strand. And then after it hits the first pixel, that pixel will actually do its own level shifting and turn that from a 3.3 volt to a 5 volt line. The problem is if it comes in corrupted or undervolt, then it's going to essentially take whatever it thinks it got on that first pixel and then replicate that down the line. So it may not do what you want. So what this is it takes it creates a breakout board for the D1 Mini, gives you a spot for a level shifter that you can put in, and then a spot for all your resistors, and then your ultimate outputs for each. So for up to 8, I'm sorry, it's not 8, 6. So 6 outputs for, I guess that's why it's called hex, for those strands. So you've got your data, your 5 volt, and your ground. So for up to 6 of those. And then also, this is something that I ran into recently with dirty power, is a capacitor to kind of clean up the power supply. So I had an issue where I was seeing some random weirdness with one of my strands. It was a 5 volt strand, and I knew it was a problem with the data line, but I couldn't quite figure out what it was. And just as just a method of troubleshooting, I put a cap between positive and negative, and turned out it totally resolved it. And it's basically a filtering cap to clean up that power line. So that's also included here, which is nice. So it's really cool looking board. I don't have one yet. I'm gonna order one, and what I'd really love to see is one of these in a 12 volt variety that actually has a 12 volt step down to the 5 volt power that the Wemos requires. And I'm not sure how you would handle the power distribution for 12 volt. I don't know if this would be enough to do that, but I would like to see something like that. So I might even try to take a stab at doing that with KiCad or something like that. I've been meaning to actually design a board, so that might be a easy-ish one for a first attempt. Okay, so here we go. Here's word drop, doing what it's supposed to do, and yeah, so that's cool. So yeah, so again, the ClockIOT from WyoLum, really cool design. If you have one of the previous Clock 3 Juniors, you can actually get an upgraded board. So it utilizes the same hardware, so the same display, all that good stuff, and even the IKEA frame. I'll put the links down below of all the sites that we used today, as well as a link to WyoLum's Etsy store where you can purchase the ClockIOT. Other than that, thanks for watching, and we'll see you next time.